A cloud chamber is a tool that can indirectly view ionization type of radiation. It makes the path of a charged particle visible in cooled supersaturated alcohol vapor.
Chemicals required: ethyl alcohol, a radioactive source like thorium, and dry ice.
Materials required: one empty plastic box, one black paper, and a piece of aluminium foil. Procedure: at first, a piece of aluminium foil is taken and stuck on one side of the black paper with the help of a sellotape. Then little amount of ethyl alcohol is sprinkled on the other side of the black paper and also inside the plastic container. Then the excess alcohol is drained out from both the container and the paper. Next, the black paper is placed on the crushed dry ice so that the aluminium foil is in contact with the dry ice. As aluminium is a good conductor of heat, it will cool the black paper faster by absorbing a lot of heat and also avoid the direct contact with the alcohol. After that, the thoriated rods are placed over the black paper and the plastic container is placed over it. We wait for a minute or so for the alcohol vapor to supersaturate inside of the container. Now we begin to see thick and white trails of alpha particles. Mechanism behind cloud chamber. The alcohol absorbed by the box container at the room temperature slowly evaporates into the air. But as the evaporated alcohol sinks towards the dry ice, it cools down and wants to turn back into the liquid state. The air near the bottom of the tank is now supersaturated, which means it is filled with alcohol vapors and is just below its atmospheric dew point. And just as water molecules cling to blades of grass on a cool autumn morning, the atmospheric alcohol forms cloud-like droplets on anything it can cling onto, the particles coming through. When an alpha particle zips through the cloud chamber, it bumps into the atmospheric molecule and knocks off some of the electrons, turning the molecule into charged ions. The atmospheric alcohol is attracted to these ions and clings onto them, forming tiny droplets. The alpha particle acts as a condensating nuclei on which the alcohol vapors forms droplets. The resulting tracks left behind looks like a contrail of airplane, long, spindly lines marking the particle's path through the cloud chamber. When a charged particle passes through the chamber, it leaves behind a trail of ions. Mist droplets form around these ions, creating a cloud track. By studying these tracks or a photograph of it, one can determine the energy and the charge of the particle that produced it. Cloud chambers were extensively used in particle physics until the 1950s. They enabled the discoveries of particles like the positron in 1932 by Carl Anderson and the muon in 1936. A charged particle, while passing perpendicularly to the direction of the magnetic field, feels a force and moves in a circular path. Alpha particles have two positive charge and mass of helium nucleus. Being a charged particle, it experiences a magnetic force, hence appears as curved and distorted path. Hope you have understood how a cloud chamber works. Thanks for watching, and to see more wonderful science videos like this one, subscribe to the channel.